Welcome. How's it going, everyone? Everyone ready for episode number 2 of SDK Unwind? Tuning in from Berlin, Germany today. I gotta say, I had one of these trips to the office. There was quite when you feel like you're sort of trying to climb a mountain and there's a big man up there pushing you down. That's how my trip to the office felt like today. I in particular came across a couple hurdles. Normally I just get to jump right into a tram and then get into another train, and I'm in the office in like 35 minutes. But today, for some reason, there was a whole bunch of challenges that reminded me of what we'll be streaming about today. Actually, like we're solving challenges, but sometimes we don't expect them um, to spring out as they do. So all of this to say, I'm just sharing how my day has been so far. It has been uh, presenting me with unexpected challenges. So instead of just hopping onto a tram and then another train, I waited for a tram that didn't come, and then I had a little jog. I went for a little jog um, to the next train, and then what did I have to do? Oh, I had to get a scooter to get the bus. I mean, it was really really entertaining if you think about it from an outside perspective. So I thought I would just share that with you guys as we kick things off here today. How's everyone doing? For those that are new, this is the episode 2. So that means we've done 3 episodes of this stream, where the stream is really an open format. Dive into the Polkadot SDK, this software development kit that allows us to write blockchains. It allows us to write application-specific blockchains that can be secured by the Polkadot network. So please don't be shy. We were lucky to be joined by people from tuning in from Twitter, as well as Twitch and LinkedIn too. LinkedIn's here and YouTube. So use the chat. I'll be keeping an eye out on the chat as we kind of discover all the things. So without further ado, I'll share my screen here. Where we can kind of get started basically from where we last left off. That's sort of my plan today is to take some tips and things that we went through and learned in the previous episodes, and keep kind of going really, whereby we have a topic today that I wanted to hone in on a little more, as it's something that we just breezed over in the last episode, which is this concept of dev mode, and it being a really useful, neat feature that Frame provides. So as we power through, we'll be actually doing discovering its key utility, and we'll be doing that actually by trying to compile some code and looking at what the Rust compiler will tell us, will yell at us if we do things incorrectly. So yes, welcome everyone. Rust Ninja, great to have you here. Rust plus Wasm equals Polkadot. Yes, that's what we're talking about. We're talking about Rust. This is all Rust stuff. We love Rust. And you know what? Also, we like Wasm too. Wasm's great. Wasm is the compilation target for the smart contracts that we have in the Polkadot ecosystem, at least the primary Polkadot natives smart contract. And thanks for sharing that. That's a good way to get hyped for this episode, where we're going to be doing all sorts of things Rust. Yeah, nice. So I've shared a little bit of my morning. Forgive me if I'm a little off today. That maybe this is just, or maybe this is my day. Maybe I've actually made it to the office after a tram that's never came. Had to like sprint to the next place and then get on a scooter. I think actually I'm really proud of myself. I'm here now. It really sets precedence for this episode. But let's stop being silly here and kind of dive in. So a little background music maybe for those that like this. Again, these series, the series of episodes is really meant to take a step back from building with the Polkadot SDK, whereby I think a lot of us are possibly new or still discovering building application-specific blockchains and using this SDK for other purposes, which we've only in these first few episodes looked at this very particular part of the Polkadot SDK, which is Frame. And that's what we're going to be looking in today, where Frame is an opinionated, it's a framework within this SDK to write the business logic of the application chains that you'd be writing. And why would you be writing application-specific blockchains? Well, because ultimately, that's sort of the key value proposition of Polkadot, which is to have blockchains that are connected to each other, they can communicate with each other, and that provide a very specific application for the network. So examples could be simply we have Kilt is a very popular blockchain that's within the Polkadot network that provides decentralized identifiers and decentralized IDs for any protocol that would need the DID standard implementation, and all of this being completely decentralized, powered by Polkadot. Another app-specific blockchain could be just a storage chain. We have Crust, for example, provides storage for other app chains connected to Polkadot. And then, these chains really can be as specific and primitive as they would like. We can add as many features as possible. Today, we're not talking about things that we're not diving into like a specific thing that we're building. Just to be really clear, I'm using this time to sort of debunk and to provide a nicer or at least an accessible way for people that know a little Rust, that are curious about what Polkadot SDK is, and just want little guidance to get started. So that's really what these first few episodes are about. I hope that we can all learn together. So one of the things we've done in the previous episodes is just we've cloned the Polkadot SDK and started kind of poking around in the Frame folder, which is where we'll be focused on today as well. So I welcome any of you guys, anyone that's keen on following along, to do exactly that while I reconfigure my screen and get set up for the next section here. Where's everyone tuning in from? Say hi. Hi, Jonathan. Good to have you here too. Awesome. Oh yeah, I wanted to. First things first. I gotta share with you guys that I'm listening to some lo-fi beats. I like to listen to some background music. It kind of keeps me concentrated, and hopefully, share what you guys are. Does anyone else like to listen to music while they code? If so, please share. Okay, yeah, some jazz, sweet. We like jazz. That's what I'm listening to right now. Some smooth jazz, rainy autumn day, cozy coffee shop. Let's do that. Sweet. Yeah, so as we're getting set up today, we've got the Polkadot SDK cloned here locally, and here I have the this. So as I'm going through my stream, I'm keeping track of the things that we do and the things that we've learned, and I do that in this scratchpad file. So if you see this scratchpad.md, like that is just us kind of keeping track of things. And I invite everyone tuning in right now to just check in with what we did last time here. These episodes don't build on each other. That's something important to note. So like, don't feel that, oh, you've missed the last SDK Unwind and therefore you'll need to be catching up before you can kind of tune in live. This is really not the case. What we do in one episode then kind of serves as inspiration for a following episode. And really, given this open format, we might be getting guests on in future episodes. In fact, I've been talking to some core engineers at Parity who are really interested in sharing some stuff. So that's kind of what we're going for. So what we're looking at right now, though, is what we did last time, because in this episode, we're going to dive a little deeper into what this dev mode thing is. And yes, but before we do that, just give me 1 second. Hi from the UK. Hey. Yes, 1 second. Just gonna get myself set up here. Yeah, so we're just I'll be like completely rewriting this, but I have this up for those that missed last episode and just to get an idea of what we did. And I think actually this says it all. Like we really dove into the like the use the like the power of actually just discovering substrate through a test mock runtime, and really stepping through extrinsics and their behavior by writing tests is a huge like piece of advice that I have to learn substrate. Okay. Ooh, my displays are correct. And what do we do here? Yes. Oh, do we do it like this? Oh, nice. Yeah, that's okay. Anyways, okay. Okay, cool. Yeah, so last time tests was a big thing we kind of went over, and we showed a super stripped down version of an example palette. We actually called it palette super basic. So I'm already jumping ahead here. I'm already jumping ahead here, guys, because one of the things that we've learned in the last episode is, so, what we were doing is we actually were hacking away at a palette inside the Polkadot SDK, inside this repository. And one of the things that I advise you guys to do is to have Rust Analyzer, because as we were using it when it was successful, having Rust Analyzer, which is just this simple extension, analyzer. It's this VS Code extension that really it's useful because you get to get a documentation right in your IDE, and also like click and discover where certain types come from. However, as you can see, it's not actually enabled in the Polkadot SDK workspace, and that's because what we were doing last time was we actually inside this repo hacking around at a new palette, and that didn't work really nicely for us because every time we did a change that we wanted to compile and run some tests, Rust Analyzer would sort of freak out and we'd have to wait a bunch of time before we could actually do anything. So let's kick this off with me kind of showing you what I've done here, so you guys can follow along too. So I have my Polkadot SDK open as a reference point. Like we'll be checking out different like examples, specifically in the frame examples folder. So let's just let me just show you guys so that we're super clear where we are here. So frame example. So you can see these are all palettes, by the way. These are all palettes that are used in various parachain runtimes, the business logic of these application-specific chains that this SDK provides us to build with. And but in this frame folder, there's a bunch of examples. And so these examples are really, really great starting point to understand some basic features of frame. So that's kind of where we're going to be living today as well. And my point was, yes, we'll be probably diving into this examples folder to see certain things in action, and then maybe actually using them in our own palette. That leads me to the next thing I wanted to address. The next thing I want to address is that instead of actually working into this in this SDK repo, what I've got here is I've done my it's an own repository. So I've done like a git init, and I have a workspace called basic palette, and I've actually ported over the super basic palette that we did last last episode. So last episode we did this thing. We literally really dumbed down the examples basic palette, where you can go ahead and check that out. It's in the Polkadot SDK frame examples basic folder. That's this palette examples basic package here. And we really dumbed it down. Like, we took everything out of it, I guess, except for this storage value. So we have a way to store some balance, and we wrote a simple extrinsic that can be called by any entity that is a signed entity. So, and you can think of this as an end user, right, submitting a transaction. And then we did a simple mutate here. So that user is that the caller of this call, accumulate dummy, is able to accumulate that value. Again, we're not going into like any use cases and stuff. I'm just trying to really highlight some features in frame, and in this case, it's a storage value using this mutate API. And aha, you see, this is already fun. Look, I've got REST analyzer going on here. Check. So Rust analyzer is a lot happier in a smaller code base. And so just to show you guys, it's actually enabled here. And back to the super basic palette, what's cool is that so you can see that we've got this dummy storage value, and then I'm using mutate. Mutate the value. I can go and see its implementation too if I wanted to, by just doing command and clicking on it. So that's pretty cool. That's pretty cool, like showcasing Rust analyzer in a very useful way, not like last episode where we spent just too much time waiting for it to chug along and stuff. So that's where you're just using the mutate API here. Great. And then we're using kill here. So this is a second extrinsic that we wrote, and it can only be called by root. So that this is a concept in frame where you can have these publicly, or these public exposed functions of your palette can be called by the system level. That means it's not a signed entity. It's it's on the system level. Like, another palette can make a call here, or practically speaking, governance calls are a root origin, where we've got some on-chain governance mechanism that can execute a call. It would be using root. So in this case, we're just also showcasing this neat little helper function that frame provides. Again, just can click into it with Rust Analyzer. Anyone so by the way, this is my setup. This is just VS Code and using Rust Analyzer. I'm not sure of any other setups. Maybe people want to share in the chat like other setups that they use. But this is what we're working with today. But yeah, always curious like what other people have set up. I know there's some other IDs people have preferences with. Okay, great. Oh yeah, and then we wrote some tests. So super simple tests. We have this accumulate dummy works test, and we just show that by adding one value, it's actually working as expected. So given this, okay, then we expect this. And then kill dummy works too. Also notice that we're checking with root origin. So in the test, what's great is that you actually get to see sort of under the hood how calls are constructed. So okay. And we also have the mock runtime here, which really is so telling about how would you integrate this palette into a like real world scenario, I guess you could say. Like use these palettes can be used by any runtime, any parachain, or any blockchain built with Substrate, because of the nature of how palettes are designed to be the runtime logic for a Substrate chain. So this mock runtime is very simple because we only use balances, and then this is our super basic palette that we use. Cool. Wow, I feel like I've done a lot of talking. I'm gonna check the chat for a sec, and then we're gonna have fun here. We're gonna have fun because we're gonna just get at it and live code with showing how easy it is to actually have this types of setup if you want to be hacking on your own palettes without needing to be in a node template or any other or basically keeping your workspace minimal around just hacking around a palette. So we're gonna do that. So hey, yay! So I'm late. So someone says, "Sorry, I'm late. What do the links in Cargo Tunnel look like with the new?" I'm so glad you asked. This is why I need you guys really in this live stream, because otherwise I can just go off on tangents, and you're keeping me in check, man. I'm really, really grateful here. So the question is, what would my Cargo Tunnel look like with the new Polkadot SDK? Thank you so much for asking. So pretty much, this is a great question because last episode we were directly in this SDK, in the Polkadot SDK itself, and so all of the dependencies are relative to the path within the mono repo. So we never really asked ourselves the question, well, what if I was hacking on my own palette in my own repository? What path would I specify here? And I've already got this set up here, so I could just dive right into showing you. So essentially, this super basic palette is what I just ported over, but the first thing I had to do was to specify my the cargo.toml file to point to the new Polkadot SDK tag. So this is actually the latest tag. And to answer your question, this is what it would look like. So we, right in this palette, we're using frame support, palette balances, frame system, SPIO, SP runtime, SPSTD, and all of these are specified like this. But there's, so that hopefully that answers your question. So we're using Polkadot v1.1, and let's just check what it looks like here. Actually, I'll wait. Yeah, I'm gonna get a browser window to show you guys. Up. Oh, boop, boop. Oh, my Mac's been kind of, not really liking things these days. Huh, that's okay. I'm just trying to okay, well, all I wanted to show you guys is if you go to the Polkadot SDK repo, you'll see that this is the latest release tag, and this means it's Well, this is actually a huge improvement in the developer experience of using Substrate, um, which is that developers no longer need to just follow the master branch. They can actually do exactly this, and it also under the hood is implies another thing that we're going to dive into right now is that all of these packages are actually being published to crates.io, and we we can do this thing that's now magical, which is just use cargo to build our project. How cool is that? Let's do this. Okay. There was a couple more questions here. Rust Ninja. Oh no. Oh my. It seems like I'm frozen. My. Oh man. Really? Yeah. Yeah. I think I need to just. I'll be right back. I'll be right back. See if it's gonna work. And I don't know if anyone can hear me, but my Google Chrome is not behaving, so I'm gonna have to force quit here. I'm back. Whew. Don't know what happened there, guys. I'm so sorry. Can I get a thumbs up if people can see me, hear me now? My Google Chrome just decided to croak on me. Okay, and I was answering a question. I was answering a question with regards to I think Rust Ninja had a question. Yeah. Yep, sorry about that, friends. This happens sometimes. What I'm gonna do now, which is for some reason, because like my Chrome decided to crash just so that I was trying to open a new tab. But what I wanted to show you guys was this. Cool. I got a thumbs up. That means I'm back. This is this is this is doing things live in the making. Oh yeah, and I was I'm still so stoked, by the way. I hope we didn't lose momentum. Um, I was very stoked about showing you guys how we're gonna just write a palette from scratch using just cargo and following the compiler as we do that. That's basically the plan for today. And then as we're gonna do that, we're gonna be discovering why using dev mode is a really neat way to like hack your own runtime. So if you want to be, prototyping a palette without worrying about things that we'll talk about today, things that are really important, by the way, things that are crucial for having a palette um, in ready for production, a palette that is secure, a palette that won't brick your chain. Well, there's a lot of things that you need to be doing when you are ready for that stage. But before that stage, you might just want to hack around and just learn about the different things you could be doing before you really commit. And in this episode, we'll be looking at dev mode, which really allows you to tinker with frame and your palette logic a lot easier. So I was just showing you that we are using this latest tag here. That's all I wanted to show you guys in before my Chrome crashed. And we're doing this in this cargo toml file exactly like that. So all our dependencies have that. Okay. There was a question though. That was also what was happening. So Justin is just asking, one question that I have about parachains connected to Polkadot is what is the most what is the fastest possible block time to cover as much as possible use cases. Um, so the so I don't claim to know the full and lengthy and thorough answer to this, as especially things are changing within, or major upgrades like that are going to happen to the parachains protocol, like asynchronous backing and stuff, is going to probably allow more, faster block times that that again, I'll tell you what I know. You can configure your substrate chain to have, as fast block times as you want if it's a standalone chain. But if it's following Polkadot, i.e., if it's connected to Polkadot, which is what you're asking here, you will, your I think it's standard that your parachain is 6 seconds. That your the block time set in your, runtime is 6 seconds. But let's maybe let's, I'll see if I can provide a more thorough answer there. Yeah, if there's any way to spin it up faster, well, again, like, my approach would be, like, you could totally do that in a non-parachain substrate chain, by tweaking the constant, which is some constant. But we're not looking at a no template here, so I can't really, like, demonstrate anything at this point. But great question, though. Also, one huge tip I didn't give, in any previous episodes is, like, anyone that has questions, or if you have a specific question that you're not sure, it could be a common question, or maybe someone had something to answer, check out the Stack Exchange. Like, that is where so many questions, um, like, common questions are answered. So, like, for example, let's see, like, block time. And Stack Exchange is really, really a great, way to learn so much. What is the possible minimum block time? Maybe this is not the answer to our question. Is there a way to calculate what the minimum block time would be? If not, could we consider before lowering the block time and how to monitor side effects of small block time? Okay. Um, and I think this answer probably gives you a very good idea of the current, um, decisions around a 6 second block time. But yeah, this we digress. But that's part of, this format here. We're allowed to digress. We can go in different directions. Great. Okay, let's dive into the sub. Just checking everything's good. Yes. Okay, cool. Uh, um, hey, Alvio, welcome. Welcome, welcome. Okay. Mm, So, I've got a kind of broad idea of what we're gonna do today here, and, I've done this. We've talked about the tag. Thank you for that question. Literally was something I was gonna talk about. And, yes. Um, mm, mm, we're gonna add a basic shell palette. So, actually, yeah, no, I'm gonna just open terminal here. Um, Basic palette. So we have this workspace, that we'll add a palette to, right? So we're gonna go ahead and do that. So the first step we wanna do is we're just gonna use cargo, right? So we're gonna say cargo new, um, and the we'll call it, uh, shell palette. And one of the things that we're gonna do is just insert a very basic, structure of a palette and try to make that compile, and then take it from there. So I've got shell palette described here, and cargo just created a structure for me with a cargo.toml file where there's no dependencies because all this dummy package does is has this main.rs with some hello world stuff. Anyways, this just comes with cargo. But we're going to delete that and actually rename this to lib.rs. And I want you guys to hold the following thought. What we have here is the super basic palette that we did from last time, but again, like very simple stuff. We went over it. But it's cargo.toml file. Sorry, inside of the package, its cargo.toml file is actually using the dependencies that it requires are being fetched from the Polkadot SDK with this tag, etc., which is totally fair game to use. But here we're going to do something a little more funky. I have what I've called this like shell, and I just pasted it in this hack.mg. So I'm gonna paste this, and we're gonna go through it. The hack.mg formatting isn't very pretty. So again, we've got just the basic shell palette. All we did is cargo new, and then I'm gonna paste this in. So remember, we have Rust Analyzer going on in the back. So the first thing we can expect is that it's gonna start complaining about no imports, or should at least. Maybe we can give it a second. But what we have here, let's quickly go through it, is this would be your very basic palette that doesn't do anything, but has the required parts. I think actually that's one of the things we looked at on last week's session, is like what are the absolutely mandatory parts of a palette. And I believe that call isn't actually one, but maybe you guys can correct me. I believe that the only mandatory part is the config trait with this attribute macro. So I think that what we'll want to do now is just to say, hey Rust, can you compile this as is? So let's try to do that. So shell, we're going to cd into the shell palette, and we're going to say cargo check. Okay, this is great. So the first thing that the Rust compiler tells us is that, wait a second, this shell palette, it's not part of our workspace. So what's going on? Like, we need this package to be part of some workspace. And so you'll notice that I actually have a cargo.toml file specified outside of these packages, where we're able to just go in there and add this shell palette to our workspace, and this should take away this error. And then actually, so just, and that's why Rust Analyzer is not picking anything up here, because it's not even being picked. It's not being picked up by the workspace. So as soon as we add this, though, let's do it. So let's just double check our name here. So it's called shell palette. Again, we're just using cargo. We're just using the powers of Rust. Powers of Rust. Okay, now we've added this to our workspace. Now, so you can see at the bottom of my screen, Rust Analyzer is using up its vitamins a little bit. But hey, it's already done. Amazing, right? Like, and now it's starting to complain to us. So we're getting there. It's complaining to us about the fact that, well, let's check it out. Failed to resolve use of the undeclared crate or module. So what should we do here now, friends? Well, this is where I suggest us leveraging the beauty of having our Polkadot SDK packages published to crates.io. And I will say, like, with long-term support. So you could be, let me just show you exactly what I mean. So crates.io is it's like the npm. It's a package, or it's like the pip for the Python world. It's where all of the Rust libraries are hosted and published along with their documentation. And the first thing we need is frame support. So let's check it out. So frame support exists here, and so we can see the versions. The last. Oh, that's amazing. Look, uh, the last time this crate was published was about an hour ago. What are the features? Okay, no, yeah, features ST. That's not that features. It just means like Rust features. But let's click into this one, and you should be able to see the documentation. Oh yeah, the documentation is also published on docs.rs. So note that like this is the stuff that's published on docs.rs. So create and then docs.rs. But when we were looking at the Polkadot SDK docs that actually is hosted at Parity Tech, the paritytech.github.io, they will be different because right now we're on master, right? And the docs.rs, we're actually at a given release. Something to note. But how exciting, right? We could literally do cargo add frame support and add a specific version, and this should take away our error. Okay, so let's get back here. First thing it says, we need frame support. So let's do that. And make my clear. Okay. So cargo add frame support. Okay, great. Just let it chug along. Okay, so cargo check. I don't know. Like, is that better? Obviously, I'm asking a rhetorical question here because we need frame system. Probably. Right now, rest analyzers may be a little confused. You see cargo check at the bottom. Yep. Okay. So what does it say? It says, could not find frame system. So let's add frame system. Cargo add frame system. And as easy as that. Now let's go and check our cargo.toml file in this shell palette. And there you go. It's added the frame support and frame system dependencies. So what next? What next? Let's see what REST Analyzer is saying. Okay. Could not find scale info. Cargo check will probably give us a better idea of what error this could be. So scroll at the top always, just to check what the first error is. It says could not find parity scale codec in dependencies. So this is basically saying that the frame support palette macro needs an additional dependency that we don't have. And anyone can tell me what parity scale codec might be. Give you a few seconds. Like anyone wants to just share what they think this scale codec library is, and what it might be, and why we might need it. Well, while we do that, I'm going to show you that it exists here, parity scale codec, and we're just going to add it. Yes. Okay, we're getting there. Cargo check. Still something missing. Scale info. What scale info? Let's add scale info. I mean, we're in the business of making the Rust compiler happy. Let's not kid ourselves. We're not really software engineers here. We're in the business of keeping the Rust compiler happy. So, what now? Yes. Oh yeah, we want to add scale info. So So cargo add scale info. Are you happy now? Oh, maybe you are. So quick detour. What is this scale codec? Well, this is basically the codec that any substrate chain uses, and it allows to um, encode and decode in a lightweight format for resource-constrained execution environments like blockchain runtimes. So it is a very important part of a palette because all of its any data type must be encoded in order to be in the runtime of a chain, and any entity interacting with the chain will retrieve that encoded value and need to decode it. And so this is why we need this library. Um, Actually, there's a page in the docs here. Yeah, I can share that with you guys. Um, the this document on scale codec provides you a description of what the codec is and why we need it. Super. We're totally doing a detour here. Oh yeah, there you go, Jonathan. Thank you so much. It's a lightweight format which allows encoding and decoding, which makes it highly suitable for resource-constrained environments like blockchain runtimes. Thank you. We just discovered the same resource. But also we'll put this here so you guys can check it out. Show. Oh, yeah. So you'll learn about scale codec. But back to our palette here. It looks like it's going to compile. Check it out. All right, so cargo check. Yes, this works. This is like super exciting because we literally just did cargo add cargo. Beautiful. I'm stoked. I am stoked. What about you guys? Yeah, so no need to manually edit cargo.toml anymore. That's the direction we're going. We're going in a direction here whereby it's going to be a lot easier to maintain projects too, and to stick to a certain release or a certain stable release of these crates that we use. So shell palette. So back to our shell palette. What are we going to do with this shell palette? It literally does nothing right now. And okay, yes. So I'm going to just step into this super basic palette that we did last time, and borrow the storage that we did. So I'm just going to copy paste that. So we had a simple storage value, and then also we had an extrinsic that allowed us to. I'm just gonna copy it like this. We had one extrinsic that allowed us to update that storage value. So let's do that. Also, I'm always curious to hear what other people would be wanting to dive into, like as we go. And I could either just write that into my Scratchpad and be like, oh, that's a good idea. By the way, I should update this right now. This is my Scratchpad. My Scratchpad. Yeah, episode 2. That was episode 1 actually. So yes, using crates.io. We did shell palette that does nothing, but it's a good starting point. It's a good starting point to build some functionality and to discover some parts of the SDK. Okay, So all I did right now is I added this storage value, and no, I'm gonna remove this call for now, just because I wanna go step by step about what the compiler is gonna be complaining about. So the very first thing is that it's complaining about this type balance that doesn't exist. In our super basic palette, we actually had this as part of the configuration type, because what we did is that we did this thing called tightly coupling this palette with the balances palette, as you can see here. So all we did was said, "Hey, config trait of this palette, can you also go um, and depend on the types of this the uh, config trait from the balances palette, please and thank you?" And that allowed us to literally use the balance type from the balances palette by calling t colon colon balance. But in this shell palette, we don't actually have that. And I don't want to get in the weeds of adding and like coupling this like we did. So I'm going to actually create a type balance here. So if I go pub type balance, and it's a U64 or U128. Let's do that. And then we can just use this balance type. Remember how generic we like things to be in palette writing world. We always will, we will um, make the types that it depends on concrete when we actually implement the palette for the runtime. That's like a very dominant mental model that you need to adopt when you're writing palettes. So, but in this case, we just created this U128, and that's just sufficient for our purposes. But what you would normally do is you would actually make it a configuration type here, and you would say like um, type balance, and then you would do this like you would. My autopilot is actually telling me that this is probably what I would do, and I think it's correct because that's what the balances type is in the balances palette. Wait, let's check this. Let's check because I think with my Rust analyzer on, I can actually really easily show you guys. So if I go the config type of my balances palette, that was pretty smooth. I can see that what this balances type is actually. It's right here. So my code, my code palette was not so far off. Let's check. It would be like this. Yeah, it's missing a bunch, but I digress. Okay. So what's the dependency update for the next tag? Yeah, so that's a good question with regards to, I don't know, if you have like a cargo.toml file where um they're all maybe using different so I think that it's going to at least be such that whatever next version bump is like on frame support will also be applied for frame system, and probably the substrate primitive libraries will follow a similar update uh, like version bump. So that's something that that you can use and that you can lean on, which is really nice. You can rely on. Okay. Hopefully that answered your question regarding the version bumps. Okay, so we have this like balance type. It's just a use, and yeah, let's just do that. It's a U128. So that's the first. That's great, right? Like we got rid of that error, and we've copied over this dummy call, which accumulates. Get rid of this. So what do we have here? It says a palette call requires a concrete weight. Um, this macro says that we need to wait. So like let's just do this cargo check. and get more. So what REST Analyzer does, it actually picks up the errors that the compiler will tell you, but let's just look at it in the compiler here. So yeah, so it's saying like we're missing this concept called a weight. Also, we forgot to just to increase by balance. And that's because normally, let's go back to Polkadot SDK. Well, normally we have like any extrinsic. We go to this examples basic palette. We'll need to have palette weight. This attribute that we pass in to um, to specify specific the weight of this call. And I really think that what would be great to do is to do a deep dive on weights. This is not this session, but mm, what we need to know in our case is that setting setting the weight of a call is actually a lot of extra work. In order to get correct weight estimations, you need to benchmark against some standard hardware that's a reference for the execution time, the amount of computational resources for a call like setDummy to take. So when setDummy is called, it costs the blockchain some resource. We need to estimate it using weights. And in order to do that, that estimation requires a bunch of extra work, like writing benchmark code, running your benchmarks, getting appropriate values, and getting values that are safe. Safe in the sense that you don't want to underestimate the amount of computation and execution time it requires to make a call, because if you do, and someone spams your chain with that transaction, you could brick your chain. Your chain can stop producing blocks because it's exceeded the maximum amount of resources for a single block of execution time. And therefore, what we're going to show here is if we use dev mode, well, we don't need to care about weights. So what I could do is annotate it like this. I could say, um, put weights to 0. And before we used to, before this dev mode existed, we would actually just do this for the sake of prototyping. Like it would just be an easy way to do it. Just put in 0. But the problem is with that is that what we actually saw happen is that sometimes people forget that they didn't actually properly set the weights of their call. And like I just explained, that's very dangerous if you're going into production. So we don't want to do this. We don't want to make it accidental. Right now, if I cargo check, it's going to be happy. It's not going to tell me anything. This is great, actually. It does give us a warning. It says we don't like to do this. This is a deprecated. Sorry, we're looking at this constant weight here. This is a deprecated way to do weights. It says please instead benchmark all calls or put the palette into dev mode. Put it into dev mode, and it'll solve your problems. So let's do that. So dev mode presumably will remove this error. Notice actually I just skipped over something right here, is that it also says you should be this warning is telling me use implicit call indices. Right now we don't actually have a call index specified, and this is this other attribute that we pass in that allows you to explicitly state at what index this call is. And that's really useful because if you're updating your palette and your palette has indices that aren't explicitly stated, well, if you're some app that's like querying or providing a service that uses your palette or your blockchain, and you all of a sudden scramble up the different calls, and your application no longer knows where to look for that specific call. That can cause huge UX nightmares and updating and all sorts of stuff. So we use explicit call indices. Again, this is for production. Like if you're writing a palette that's going to go to production, and right now we're not, so we don't need to really care about that. So let's go ahead and add dev mode, and these warnings will probably disappear. Dev mode. Yes. Now we're in dev mode. And I think the compiler should tell us. Oh, it doesn't. Let's see. I was gonna say that the compiler should tell us that we're in dev mode, or should say a warning that, oh, this pilot is in dev mode. But I think it's pretty explicit here, and it wouldn't hurt to have some CI job if you're like working on your own parachain, working on your own palette library, to just check that dev mode is not activated for any palette. I think that you wouldn't be able to compile. You wouldn't be able to build it without a warning anyways. Let's see. Cool. Yeah, so you need to put so you definitely need to put wait info. I hope I just explained that. Like when you're not taking down the route of like going straight to production, or at least putting when you want to be doing what we're doing right now is hacking at a palette, it's important to know that these things are crucial for production. But here we don't need to put wait info. And yes, we have like default weights. Again, like I think we should dedicate an entire session just looking at weights. But the point is that it's a lot of extra work to do, and it's also crucial to get right. So at some points you want to just do what we're doing right now. Yes, weights are black magic. Read the doc that I shared. Read this doc. Actually, I shared it last time. I'm here. I'm gonna show you this doc, and there's some good enough material here that kind of will give you an idea of no, it's not in the how-to guides. And I want to say also, while I'm showing you these docs, is that there's a lot of things that are outdated here, or at least that we're working on improving. Um, and things like, when we were starting to document the things that you could be doing with Substrate, one of the things was to do custom weights, where you could write a custom weight based on some conditions. Like for example, like the weight of this call will be X depending on the account type, or depending on the origin or some custom origin, and will be of value Y in any other case. Something custom like that. And I mean, you can do this with Substrate. That's the beauty of Substrate, but it's highly not recommended. Like that, you would never want to do. Um, oh yeah, benchmark. You would never want to actually take that risk with your blockchain runtime, because it's just too much of a risk to take, that something can go wrong and brick your chain because of a misconfigured weight. So weights are really important, and this is a great place to start to learn about, to demystify weights, to make them less like black magic. And I'm gonna share the link here. Yeah, so this link right here, docs.substrate.io/test/benchmark. This explains like why to benchmark a palette, how it works, the relation between the execution time and actually adding fees, or fee structure, to the amount of compute of an extrinsic requires, etc. So back to our question. Another question came in: is this episode dedicated to a topic? This episode, thank you for asking. Thank you for asking, because people that are maybe tuning in are also confused. What we're doing in this episode is we are looking at dev mode, and the topic being using dev mode as a feature when you're prototyping a palette. And we're doing that by also just discovering and writing our own palette here in a nutshell. Oh, so it didn't give me any warning about that, but that's fine. So yeah, we just added dev mode, mm, and now I wanna show you guys another. Okay, so I wanna show you within the examples palette, in the examples folder in the Polkadot SDK, dev mode, and what it shows. I wanna hone in on this here. So one of the things that, um, dev mode removes the burden of when you're just wanting to, like, hack on your own, palette and experiment with things, is the ability to not worry or need to worry about bounding your vectors. And I'm gonna demonstrate this by actually writing, or using a vector. So we're still using this storage value. We're storing a single value, but what if we wanted to store a vector? That means it's some collection of items. They could be objects, they could be single U64s or whatever. Um, and yeah, let's just go ahead and check that out. So I'm gonna actually go into the super basic palette. First of all, show you guys that it actually works. Where do we go here? Okay, so that, cargo test. So we've been test for this before. And now I want to change the storage value, or actually I'm going to do a new storage value. So we have our palette storage, and we will just go ahead and create a something storage value, but a vec. And yeah, okay, no, actually, I already have this palette in dev mode. So what we can do is just stick to our shell palette where we started today. So okay. First things first, let's remove dev mode and focus on what the compiler is going to complain about. Oh, sorry, I'm missing something here. Let's remove dev mode. Yeah, I'm just going to remove this call because we know now that dev mode like a normal palette without dev mode will complain about not having weight annotations. But what else? What else does it help you with? And that's what we're looking at right now. So I want to add the storage value. So let's say it's just a storage vec. We'll call it dummy storage vec. And pretty simple. I just want to have a vector of, I guess we can do something fun. We can like put in, yeah, we could, well, maybe if you guys have an idea, share with me. We could make this an object, we can make this anything, but right now we'll just stick to account ID. So you can think about this as like some storage, some piece of storage that's just keeping track of a list of like uh, yeah, like uh, top players that this palette is keeping track of, and anytime that storage this piece of storage gets updated, it appends a new player to this storage. Again, we're just trying to tell stories about just using these frame features. And yes, why is Rust Analyzer complaining already? Well, it's saying that we actually don't have this vec, and so let's just add it. Okay, can't find vec in scope. Okay, scale info preload vec, great. We've got that. That's no longer complaining. And now, let's see what's going on here. Shell palette, cargo, check. Okay. It says the trait bound vec max encoded length is not satisfied. Can anyone tell me what they think this means? Feel free to just like shoot in the chat. And while you do that, I'm gonna go ahead and kind of pretend like I'm visiting this for the first time. Like, what would I do? How would I approach what the compiler is telling me? And this could happen if you're creating some object that is not satisfying what this error is pointing about, and like, how would you approach that? So first thing I would do, I would like go to the Rust docs and search for max encoded length and try to understand like what it is. So it's telling me that items implementing max encoded len have a statically known maximum encoded size. Some containers, such as bounded vec, have enforced size limits, and this trait can be implemented accurately. Other containers, such as storage map, do not have enforced size limits. For those containers, it is necessary to make a documented assumption about the maximum usage and compute the max encoded length based on that assumption. What are we learning here? What are the things that we can take from the knowledge of when we were talking about weights? How we're in a constrained environment. I think someone in the chat said that, right? It's like when we were talking about weights, we had this like we need so this is in the context of like scale codec, and where we have this what we can take from that, at least, is that we're in a resource constraint execution environment. We need a thing like scale codec, a very compact way of representing data. We also are constrained with weights, whereby we're constrained in the execution time any given function will incur to our chain. And but there's an extra thing, which is that the parachains on Polkadot, in order to accurately determine this thing called POV, we need to bound any data structure, because then we are not then we could exceed so then it'll be very difficult to estimate what that POV is. So what is POV? Again, like, okay, where would I go from there? Would be like, okay, POV. But so POV is like a completely different tangent here, but essentially every parachain needs to submit some proof, and that proof needs must be as small as possible. It can't exceed a maximum size, and in order to estimate the ceiling limit of that size, we need to accurately calculate that size. So for example, let's go back to our vec here. This vec, as it is, so we have a storage item that says this is a vec that could be as big as you possibly want to make it. There's no enforceability on that level. But when this palette is actually being used inside of a runtime in production, well, we need to know what the maximum size is for this vector in order to calculate this thing called POV. So the proof of validation for parachains. the that is a whole parachain protocol topic that we're not going to go into. But what's important for us here is to appreciate that that is a crucial part of runtime development. Is that we need to be bounding these these data structures. So back to max encoded length. Okay, so and then like actually, I'm gonna just show an example in the Polkadot SDK, and then we're gonna just put this right into dev mode, and it won't give us that error. Again, we're trying to highlight the use of dev mode. So if I go here, I'm going to go to any palette just to show. Oh, dev mode. Um, I'm going to go to. Ah, there you go. Cool. There's one here. Okay, so this is just one example. Also, like side plug here of like just a tip if you are ever curious about how certain things are implemented, go like your gold mine of a reference is the SDK itself. So do what I just did. Try to search for a way of an instance where this might be happening somewhere else in a palette that's in production. Right now, I've just fallen on the bounties palette. Great. So palette bounties is actually used in Polkadot and in Kusama in production. And this is just a palette that allows people to post bounties and get funded by the treasury, etc. This is just to say that this is actually in production. So okay, what we're looking at here is that we have this special data structure called bounded vec. So this this would have been a vector, like this would have been just vec with like just bounty index. This is just this storage value is trying to keep track of the indices for each bounty approval, I guess. Yeah, bounty indices that have been approved but not yet funded. And you would expect to just put a vec right in storage. What I'm trying to demonstrate is that that is not what you would do. You would actually have this thing called bounded vec. And what does bounded vec do? Let's go check the docs. So bounded vec is actually provided by frame support. And all it is it's a vector with a specified maximum size. So we'd also notice that like again, like this is a little bit more extra work that you'd be doing if you're just wanting to like prototype with the palette. You know, you might want to not need to go through this extra work. But what does this extra work mean? First of all, it means that we're using this special type, and then it also means that we need to specify what the maximum value will be. So in this example, max approvals is probably going to be in the configuration trait of this palette. Let's see. Actually, why isn't it? It's not. Oh, maybe because it's from. Yeah, it's from it's probably like coupled. Is it coupled to some? Yes. Aha, there you go. So it's coupled to the treasury palette. So I assume that max approvals will be in here. Again, I don't have a analyzer, so I can't just jump right, left, and censor. But let's just actually persevere here. Let's persevere here. Okay. And then I should have a max approvals. Oh, no. Max approvals. Yay. So max approvals in the bounty palette is actually being taken from the treasury palette. And it is the upper limit in this bounded vec. And we're using this value that, again, substrate, we only make things concrete when they're implemented for the runtime. So this could be, depending on your implementation, however big you want. And let's just like actually go the last step to kind of fully depict what I'm trying to show, which is this adds a lot of extra stuff, where you want to have a bounded vec that can be generically configured. So it should be max approvals in some runtime implementation. Let's see. I'm going to do files to include runtime lib, runtime source lib.rs, maybe. No, that's just going to go like lib.rs. Yay. So in Polkadot's runtime, you can see that then this max approvals from which is just one of the types that's required for the palette treasury configuration. It's specified here. Doesn't really say much because it says type max approvals equals max approvals. So question is, where is max approvals defined? And it's actually defined up here as a parameter. So there's only 100. This vector can only be of a maximum size of 100. And that's very important when you're going to production. But when you're not, when you don't care about these things, what do? You can use dev mode. That's exactly the whole point of this. So dev mode will say, yeah, you know what, Sacha, we know what you're doing. You should know that as soon as you take dev mode out, you're going to have to do all those extra steps and make this a bounded vec with some max value. But here, don't worry about it. You can just use a vec, a traditional vector. So that's kind of, that kind of sums it up. So now maybe we can actually just finish this off with making this put something in this in the storage vec. So accumulate dummy. We'll do like add. Yeah, I can do that. So I want to do pub, just make a new function. So I'm going to do add add to vec. I think we can just do this. Always origin, which comes from our frame system. It's a nice, neat IDE. Oh, origin 4. And we'll make this not increase. So I would just do like actually great. Thank you. Account ID T account. I don't want to make the autopilot, the code pilot do everything, so we can go through it. So first thing we do is check the origin, caller, ensure signed origin, and that should throw an error. If not, and now we want to do dummy storage vec, just following here. Make sense? Oh, we always need to return a result. And in this case, there's no error. By the way, there's no error handling here, right? It's like normally you would kind of catch some error that you would want to surface. So it would be like, first, like for example, check that this account doesn't already exist, and then we would throw an error. If you guys want to do that, I'm happy to. But that's pretty much what I wanted to, or like, okay, now let's just see. Fail to resolve use undeclared type T. Okay, what do you mean? Let's see. Let's just cargo check this and see what the compiler is saying. Oh yeah, I think I did something silly. Like I'm just not in the. Yeah, yeah. I'm not in the call block. Oopsies. I have to be in the call block. And that makes sense because then otherwise Rust just treats this as a module. Like we can have like helper functions that are outside of the call block, but everything in the call block then now it resolves to um, picking up where account ID is coming from. So doing storage back, did I do this correctly? Maybe not. Oh yeah, let's go and see what one I would use then. Vec dot, yeah, vec dot, what would it be? Um, no, I want to do that. And let's go see the docs. Okay, storage value. On the storage value, whoop, whoop. I think I missed a lot of people in the chat. Sorry, let me just look at that now. Yeah, so hopefully I made this clear. So using a bounded vec, yes, like you must always be using bounded vecs. Dev mode just makes it easier that you don't need to do the extra steps of like writing a bounded vec if you just want to be experimenting. So hopefully I made that really clear. Really want to emphasize that this is not, we are not saying, and please, uh, just say this out loud so that you have this internalized. We are never saying that vec is the solution, but using dev mode allows you to use vecs without having the headache to use bounded vecs, which would be a better way to do it if you want to be production ready. Exactly, Jonathan. Yeah, exactly. You want to limit the size in order to allow the protocol to stay within the required bounds and prevent it from growing. Cool. Okay. And then what was I going to do here? Oh yeah, I just want to see where. Yeah, just push. It's put. But, let's see. And just for the reference, right? That's oh yeah, that's why. Method put for mutable reference. Uh, pointer. No. Sasha, what are you doing? Well, let's check what. Let's check how we would use this in the context of like the bounties file, like we were looking at. So, yeah, down here, this would be like okay. Yeah, it would be a try append. Oh, and this is so this shows also that like you would want to catch the error whereby we maybe have we have reached the maximum size of vec. If we do a try append, that should look here. We want to be always super trying to. Oh, my vec is an option. Wait, help me out. What am I? Yeah. Wait. So okay. Oh, this is me just following the code pilot. Maybe I should have done that. Okay, so I want to do. uh, no, no, no. Follow this pattern. Try a pen, put some value, and then I will come in here into it. Oh, but yes, yes, I know what we're doing here. So vec is an option, that's totally true. Vec is an option because there's no default for it. So this is not gonna work. What I'm trying to do right now to demonstrate this is not going to work because in our storage item, this is actually so right now, what we have, the way we declare the storage, it's using the default value query, and you can see query kind here. That it's so we actually looked at this last time, and in the last did we do this last time? Well, we need to actually specify what the query type is, and so actually this is depicted in the example palette. Let's check. In the example palette, we have basic and query. Yes. So so yeah, thank you, Jonathan. The what we're trying to do here is just to add to this fact to this fact that it's currently an option, and the default is option query. So it'll so in the storage layout, it'll either be none if there's no value, or it'll have a value, but wrapped as an option. So some or none. Um, but if we want to have some um, uh, like specify some default, in which case it would be probably suitable here. I'll add value query, and this should do the trick here, whereby then I'll just specify some default value for that. So let's do that. Value query, value query. Oh no, sorry. Wait, nope. I didn't mean to be there. Don't go there. Be here. Yay. Up. And now, uh, and the account ID is some default. So now let's see. Let's see this. This should get me happy. Uh, yeah, 8 pounds, not satisfied. Let's see. That's interesting. It's it's asking me to still care about the bound. Interesting. So that means that maybe we can improve this dev mode feature that will, okay, interesting. If anyone has any comments here, it would be interesting to see what you guys think could be. So we've got a vec, we've got value query, so it's a default of account ID. Let's just, for simplicity, make this a vec of U32s, and we'll also do just like value, so we know for sure the default. like the, you know, so the trait bound is not satisfied. Oh, we need encode like. It's not implemented. Oh, that's where I'm missing a macro probably to, yes, to do encode like. I think if I check here, let's see what it is. I'm gonna derive encode like on that. Yeah, I'm not too sure, and I personally don't want to go down this rabbit hole right now. But this is this is a little annoying actually, because I want to just put, and it ain't doing it because of this. Yeah, bummer. So close, so close. Um, yeah, but yeah, hopefully this is probably a good place to end right now, and dig in a little deeper on the in the next session. And really, like, what I wanna be able to do here is go a little deeper into these APIs, get more and more familiar with specifically the storage APIs and write tests for them like we did. Um, but at this point, I think this is the takeaways that I really want us to have here, is that we have dev mode that allows us to, um, use Vex and storage without caring about the needing to bound your Vex that would require you to, uh, do a whole bunch of other stuff, like having a max value set in your config trait, and, it also allows you to forget about weights until you're ready for going to production. So some really neat feature that I really wanted to highlight, um, and, um and yeah, hopefully then that gets you guys started a little easier with building your own palettes. And also what we did in the very beginning here is that, our like, we've never done this ever before. I've I've not really seen it, but this is a really great way to just use cargo where you create your new package, and then you can just add these imports manually. And as you, like, chug along, you might need more libraries and packages from the Polkadot SDK, and that's kind of what we demonstrated today. So hopefully that was uh, that was useful. Yeah, I'm I think that's a great way to stop. What we usually do in these sessions is we go and answer one of these questions that's happening on our Polkadot Devs Twitter, where we have quizzes that happen every Friday. And what I like to do um, uh, at the end of each session is to like answer one of these questions. So last week's question was it last week? Yeah, it was last week. Was this? So quick, anyone who wants to like add to this, or anyone who wants to tell me the answer here. The question is, what does the Inklang framework enable developers to do with the Polkadot ecosystem? Tick tock, tick tock, tick tock, tick tock. Well, is it design websites, smart contracts, mine cryptocurrencies or trade tokens? The correct answer is it allows developers to write smart contracts. Interesting. Yeah, there's always a variance of um, um, answers here. So interesting to see that. Definitely not design websites. I mean, the majority is there anyways. And yeah, I think now, like, wrapping up, what I've learned here is that, the the dev mode might be missing this concept of making it like we shouldn't need to annotate the the spec with any extra stuff. But that might be something that I'm missing. So if you guys have any ideas and stuff, feel free to write to me or write in the chat. Um, was it there last week? Oh, sorry. Where's smart contracts? No, that was a different one. I'm pretty sure that that was a different one. Yeah, yeah. It's not because I would have not seen it then this way, and there's 2 days left for it. Well, hopefully, you guys have a great rest of your week, and we'll stay tuned. We'll stay tuned for the next episode. Thank you so much for tuning in and everyone who's participating. We'll be streaming every Wednesdays. So we'll see you next week. Cheers.